Okay, carrying on with our review of the Year 13 applied test. We're looking at the first of the mechanics questions, and this one has a lot of marks going with it. So take time, make sure you understand everything that's going on here. So the ball is thrown vertically upwards from a point 80 meters above the ground, and we need to find the speed at which it strikes the ground. So the ball starts here and finishes 80 meters lower. If we're defining up the page as positive, that means that the S of our suvat is going to equal minus 80. Let's go through and work out the rest of the things that we know. It's thrown upwards with a speed of 16. The speed at which it hits the ground is what we're trying to find. The acceleration will be minus 9.8 meters per second. We know that because that's gravity. And t is not given and not actually necessary in this question. We're looking then to decide which formula to use, and in this case it makes sense to use v squared equals u squared plus 2as because we have all of the relevant information. I'm going to go ahead and substitute everything in there, so v squared will equal 16 squared plus 2 times minus 80 times minus 16, time to get the calculator out, and I get that v equals 42.7 meters per second, including the units. That may be more accuracy than it's needed, but that's okay. Anything which rounds to 43 should be acceptable. I'd be happy with that answer. Okay, moving on to part B. In this question, we're asked to find when the ball is above 85 meters. It starts at 80, so we need this distance here to be greater than 5. So I'm going to work out when it is at 5, which it should happen twice because it follows a parabola like so. You can imagine that's the 85 meters. We want to find the time at this point and use that to calculate the time that it's above. Okay, so they're going to use s equals 5 and again go through and work out using the suvat the things that I'm interested in. Again, I get this, write in the values that I'm interested in. I want to find t, so the formula that makes sense to use here is s equals ut plus a half at squared. Substituting in values, I get 5 equals 16t minus 4.9 t squared. Rearrange that to be solvable. 4.9 t squared minus 16t plus 5 equals 0. I'm pretty confident that I've got 2 marks out of the possible 6 by conducting myself, by getting to this point. We need to solve this now, and the quickest and easiest method is the quadratic formula. Now, of course, you could use the calculator, but if you do so, you still need to show workings. So I'm going to solve using the quadratic formula. As if by magic, the formula appears with the substitution completed, and now that tells me if I complete that calculation, I get that t equals 0.35 and t equals 0.292, I believe. Okay, now that's great. We now need to calculate how long the ball is above that above that 85 meters, and that will be the difference between those two values. So the value that I'm interested in, the time above 85, will be given by 2.92 minus 0.35, which I believe comes to 0.2, roughly 0.257. No, 2.57. 2.57, which rounds to 2.6, which is the answer that they were looking for. Happy with that? Good. Okay, that takes us on to part C. We're now asked to calculate the height reached by the ball after it rebounds. Now, we need to take our answer from the first part here to calculate u. We're trying to find S, that's the value we're looking for. We need to calculate U. Well, that's a fifth of the answer that we got in the first one. We know it's a fifth because it tells us in the question. So that's a fifth of 42.7. V, well, when is it going? When is the greatest height actually achieved? That's when the velocity equals 0. And again, we know that the acceleration is minus 9.8. And t, not relevant to this question. So I think I will use v squared equals u squared plus 2as again. That's 0 equals 8.54 is what I get for the u value, a fifth of 42.7, minus 2 times 9.8 times s. So rearranging, I can get that, and I can see that s equals 3.72 meters. Okay, all good.